In our research, we were interested in how students' motivation changes shortly after the transition to post-secondary education in math-intensive STEM fields. So for instance, in science, technology, engineering, and mathematics programs. We know that many math-intensive STEM fields in higher education are plagued by particularly high dropout rates. For instance, in Germany, every second student enrolled in math or science programs drops out of university without obtaining a degree. These high dropout rates can incur great societal and personal cost, for instance, because of lost career opportunities and interrupted educational trajectories. We know from prior research that low levels of motivation and achievement are two of the main reasons why students decide to drop out of their math-intensive study programs. A few studies have started to examine how students' motivation changes after the transition to higher education, but we still know relatively little about this very crucial time immediately after the transition. So for instance, the very first semester after the transition to post-secondary education. So imagine you're a very good high school student, you're interested in math, you're doing really well in math, so you decide to enroll in a math-intensive study program, but then suddenly you find yourself in an educational context where many students are high achievers. You're not the best anymore. There are many students who are just as good as you are. And you need to adapt to math as a scientific discipline in contrast to the type of math that you've learned at school. You also need to structure your learning more independently compared to the school context, and so you're really overwhelmed by this new educational context. So the main question in our research was, are potential motivational declines shortly after the transition to math-intensive STEM fields part of this initial adaptation to this new educational context, or are they really warning signs of later academic difficulties and dropout intentions in math-intensive STEM fields? So to answer our research question, we used a longitudinal study design to examine changes in students' motivations across the semester. The students in our study were enrolled in study programs in physics, math, or math teacher education at a German university. We followed the students in required math courses in their study programs, so these were very challenging and mandatory math courses in the first semester of their respective study program. And in these courses, the students had to submit weekly math worksheets in order to qualify for the exam at the end of the semester. So what we did is we went into the lectures at 6 time points during the semester and asked the students to fill out paper and pencil questionnaires that asked them about their motivations. So for instance, how interested are you in the content that you're currently learning in your math course? How confident are you that you can be successful at the exam at the end of the semester? And how stressful is it dealing with the content of the math course? So for instance, working on the weekly math worksheets. And another thing that we did is we wanted to link students' motivational changes with their study success at the end of the semester. So what we did is we asked the students to indicate how satisfied they were with their study program at the end of the first semester in STEM fields. Another point was that we were interested in students' exam performance. Most students actually gave us consent so that we could access their exam performance at the end of the semester. And because we went into the lectures and were able to see who's attending each lecture, we were able to infer a potential course dropout across the semester based on who was present at each of the data collections. So all in all, we were able to link motivational changes across the semester with students' study success, so their study satisfaction at the end of the semester, their exam performance at the end of the semester, and whether they dropped out during the semester out of their math course. So our main finding is that the students experienced a motivational shock immediately after the transition to post-secondary education in math-intensive STEM fields. So immediately means from week 2 to week 3 of the semester, their motivation really crashed. This was a very sudden and sharp decline, for instance, in their interest in the content of their math class, but also a decline in how successful they think they can be at the exam at the end of the semester. Another thing that we found is that students' perceived stress and effort needed to be successful increased sharply during this time from the second to the third week of the semester. And after this initial motivational shock, there was relatively little change in students' motivations for the rest of the semester. So it is really the case that their motivation crashes immediately after the transition and then remains relatively stable at a comparatively lower level. Importantly, another thing that we found is that this motivational shock coincided with the first time that the students received performance feedback on their weekly mandatory math worksheets. Importantly, we also found that female students and students with comparatively lower grades in high school experienced a somewhat greater motivational shock at the beginning of the semester. The key question is this motivational shock part of the adaptation to this new educational context, or is it also a warning sign for later academic struggles at the end of the semester? Here, we looked at links to students' end-of-term academic success, and we found, no, it's not just a part of the adaptation to this new educational context. It really matters for students' end-of-term academic success. So even after controlling for students' gender and their prior achievement in high school, we find that the stronger the motivational decline immediately after the transition to higher education, the worse the students performed on the exam at the end of the semester, the less satisfied they were with their study program at the end of the semester, and the more likely they were to drop out of their math course during the semester. So some of them didn't even make it to the exam at the end of the semester. So one key question, of course, is why should we care about this motivational shock? Our analyses show that this motivational shock is not merely part of the adaptation to math-intensive study programs. It is also a warning sign of later academic struggles and dropout intentions in math-intensive STEM fields. From a research perspective, our study is the first to show that students experience such a motivational shock immediately after the transition to post-secondary education, and that this shock has consequences for their end-of-term academic achievement. From an application point of view, we need to think about what we can do to help students with the transition to math-intensive study programs. We could think about what types of feedback practices we use so that students can benefit from these math worksheets. Our analyses showed that the feedback was likely a contributing factor to this motivational shock, so we could think about how to structure this feedback in a more motivationally supportive way so that students can actually benefit from this feedback. For instance, we could use formative feedback practices that help students to get more experience with this content and get better at the content of their math worksheets, for instance. So what we've done so far is we identified this motivational shock, and we saw that it's not just a part of the adaptation to this new educational context in math-intensive study programs. It is also a warning sign of later academic struggles and dropout intentions. But what we still don't know is which students are most at risk of experiencing this motivational shock, and in which contexts is this motivational shock most likely to occur. So we saw that female students and lower achieving students were more at risk of experiencing such motivational declines, but our sample was also quite homogeneous, and we need more work to identify which students are most at risk of such declines. Another important thing is what context-specific characteristics are contributing to such motivational declines. These math courses in the introductory phase of math-intensive study programs are often quite challenging, and many students perceive these courses as highly competitive and having a sort of weed-out culture that wants to get rid of students who are supposedly not capable of being successful in STEM. So how can we actually implement a motivationally supportive climate and help students recover from potential motivational shocks and ease this transition to post-secondary education? Another point is what types of motivational interventions we could use. There's really interesting work on so-called utility value interventions, and these have been shown to work in boosting students' motivation, their achievement, and retention in STEM. These interventions ask students to reflect on why the course content is relevant, for instance, for their personal lives or for their studies or future careers. But these interventions are also quite hard to implement, for instance, specifically in math-intensive STEM fields, and we also don't really know why they work for some students but not for others. So one point I think is really important is that we need to work together with instructors, benefit from their expertise as instructors in math-intensive study programs, and design these interventions and improve these interventions together with instructors as core features of a particular math course.